Hello and welcome to our last thought with Chapter 7 here, estimating population parameters from a single sample. We've got all the big pieces, all the required pieces for this course, but I just wanted to close out the chapter both literally and figuratively and give you some ideas as to what you could do if you don't have a proper normal distribution, right? So everything we've done in this chapter, and actually most of the things we've done in the entire course, have been about, implicitly or explicitly, a normal distribution. And that's totally reasonable. Most of the time, as a statistician, we will work in a population that is either perfectly normally distributed or close enough to a perfect normal distribution. So, hey, it's totally fine to work in normal distributions and use the processes we've done to estimate those population parameters. That begs the question, though, what if it's not normal? What if it's a population that is not normally distributed? What do I do? And I'll give you an example. Eye color is not normally distributed, right? Skin tones, you can kind of come with a way to do it, like percent of melanin or something like that. But eye color is genetic in a different way, and it's not a normal distribution. Brown eyes, the dominant trait, dominates the population of the world. Blue eyes is a next, which is significantly lower, and then significantly less than that's pretty much everything else. Green eyes gets down to 1% of your overall population. And for your albinos, vampires, and other such things, the violet eyes and the gray eyes and the red eyes, that's 0 plus. That's effectively 0%. So let's suppose you want to estimate the distribution of eye colors of people living in Laverne, Tennessee. That's a reasonable thing that you would want to do. Maybe you want to make some demographics for people living in Laverne. So one thing you could do is, of course, look at the face of everyone in Laverne, write down the eye color of everyone in Laverne. But to be more practical, let's just take a sample of people living in Laverne. And like we've been doing, let's use a confidence level of 90%. Now that's good and bad, but something's missing from that. And that's shown here a little bit by this massive gap. Something's missing here. And that is, how do we measure eye color? Right? In statistics, we said this in day one, we've got to turn things into numbers and deal with the number system that we come up with. So can I make something like this? Can I make a list of eye color, brown, blue, hazel, amber, green, others? 1, 2, 3, 4, 5, 6. Does that make sense? Right? If I had one person with brown eyes and one person with hazel eyes, does that average out to be blue? Well, no, obviously not. Right? We've got to come up, before we do anything else, with a meaningful way to quantify eye color. Because again, this is not normally distributed. I can't be like, you're this percent of the way to brown. You either are brown or you're not. Or you are hazel or you are not. You're green or you're not. So here is how we're going to do this. We are going to do sample proportions, or proportions in general, for the population, and we're going to do it just for brown eyes or not brown eyes. We can do that. And if we want, we could do it again for blue eyes or not blue eyes. We could do it again for hazel eyes or not hazel eyes, or amber or not amber, or green or not green, or vampire or not vampire. We can do those things because this is our proportion system. Either you've got a person who has brown eyes, in which case we'll give them a 1, or they don't, in which case we'll give them a 0. And this is something we can deal with. And in fact, I bring this up now because this is a very useful tool when you go between what's called categorical data, like these eye colors, to numerical data. And the way you can go from categorical to numerical is with proportions. 1 is I've got what I want, and 0 is I don't. So there's our plan. And we will look in the next video of how to build this for a non-normal population. I will see you ahead in the next video.